This is Jayanthi Thalapathi from Gateway the Complete School. So today we are going to see about the order of reaction. Okay, so in reaction kinetics. So here order of a reaction we can find out by using three methods. Okay, so we can identify the order of reaction by using these methods. So one is by plotting a graph of reaction rate against concentration of reactant, and also by using concentration of reactant against time, and also by plotting a graph to find out, to deduce successive half-lives from graphs of concentration against time. Okay, so today we are going to see about the plotting a graph of reaction rate against concentration of reactant. Okay, so this we are going to see now. So plot a graph of reaction rate against concentration of reactant. So this is the graph. So here this is the y is the reaction rate. This is reaction rate, and the x-axis, so y-axis is reaction rate and the x-axis is concentration of reactant. So concentration of reactant, yeah, you know the unit, right? Mole per decimeter cube. So that is. So here we are going to see the zero order first. So what is zero order? When the reaction takes place, here an example is given over here, 2 moles of ammonia by heating. So when hot tungsten react, so as a catalyst, this releases the nitrogen and hydrogen. So in this reaction, if you see the rate NH3 to the power 0, the rate against the concentration is horizontal line, right? Here you can see the horizontal line. So the horizontal line shows the reaction rate does not change with the concentration. There is no changes against the concentration. So this shows the zero order reaction. So that's why I have written zero order over here, and the rate of reaction is K. Why it is K? Because NH3O, the rate constant is, the concentration is 0. So 0 means anything to the power 0 is 1. So K into 1, that is K. So only K, rate of reaction is only K, I have mentioned over here. And if you see the first order, so zero order, because of this, there is no, the reaction rate does not change with the concentration. So that is why it is zero order reaction. And if you take first order reaction over here, N2O, nitrous oxide, when it reacts with gold, gold acts as a catalyst over here. When this reaction takes place, you are getting these as a product. But in this reaction, the rate equation is, if you see KN2O to the power 1. Why it is 1? But 1 you can write like this, because 1 you no need to write anything over here. So K, the square bracket N2O. So square bracket shows, already I told you, it is change of concentration. But if you see in the graph, the plot of reaction against the concentration is inclined straight line, right? So this inclined straight line, if you see here, it starts, line going through the origin, right? So the rate is directly proportional to the concentration of the reactant. So the reaction rate is directly proportional to the concentration of the reactant. So doubling the concentration of the N2O doubles the rate of reaction. That is what you are understanding from this, right? So now if you see the second order reaction over here, NO2 reacts with CO and you are getting NO and CO2. So in this reaction, the order is KNO2 to the power 2. So this shows, if you see the plot again, the plot of reaction rate against the concentration shows upwardly curved line, right? The upwardly curved line shows it's a second order. So the second order, if you shows, if you see when the concentration of NO2 doubles, the rate of the reaction increases fourfold. I mean, when you write, for this I'm showing here, when the rate increases, rate of concentration, if you take 1 mole per decimeter cube, then the rate equation is K 1 to the power. This shows 1K. But if the rate of the equation, the concentration increases to 2 mole per decimeter cube, then this gives you K2 to the square. Okay, it doubles, right? So when the rate of reaction increases, doubles, then the rate of reaction increases fourfold, I said. So here 4K, then the value is, right? So now this is how we are calculating the order of reaction by using the concentration of the reactant. In the next video, we'll see about the other two methods. Okay, ta-ta, bye-bye.